This is a video from the Chapter 10 review. Let's take a look at 2a. We have x equals natural log of t, y equals 1 plus t squared, and the specified value of the parameter for this problem is t equal 1. And the directions say we want to find the slope of the tangent line to the given curve at the point corresponding to the specified value of the parameter. Now, dx dt is 1 over t. dy dt is 2t. And that's going to allow me to find dy dx. dy dx is dy dt divided by dx dt. But that's 2t over 1 over t, which is equal to 2t squared. Therefore, dy dx evaluated at t equal 1 is equal to 2 times 1 squared, which is equal to 2. Let's take a look at 2b. Suppose we have x equals t to the third plus 6t plus 1. Then we have y equals 2t minus t squared. And then from here we have t equal negative 1. dx dt is 3t squared plus 6. dy dt is 2 minus 2t. Okay? And so that allows me to get dy dx. dy dx is dy dt divided by dx dt. But that equals 2 minus 2t divided by 3t squared plus 6. So dy dx evaluated at t equal negative 1 is 2 minus 2 times negative 1 divided by 3 times negative 1 squared plus 6. But if we simplify, we get 4/9. Now, 2c is interesting. This is not going to be on exam 4, but it can be on the final. So I thought it would be worthwhile to go over it. Now, here we have r equals e to the negative theta, okay? And theta equals pi. So a natural question is, what do we do with s? But we know that x is equal to r cosine theta. Y is equal to r sine theta. Okay? Now notice that r is a function of theta, right? And so this is what we do. We're going to take dy d theta. And I'm going to apply the product rule here. So we're going to get dr d theta times sine theta plus r cosine theta. Now, there's a couple things to keep in mind. Remember that r is e to the negative theta. dr d theta is negative e to the negative theta by the chain rule. And so, therefore, dy d theta is the following. You're going to take negative e to the negative theta, right, times sine theta plus e to the negative theta cosine theta. Now, let's go to the next one. So x equals r cosine theta, right? And I'm going to do it again. dx d theta is dr d theta cosine theta minus r sine theta. So this is just product rule. But again, let's remind ourselves, r equals e to the negative theta. Dr d theta is negative e to the negative theta. And so this is negative e to the negative theta cosine theta minus e to the negative theta sine theta. So dy dx is dy dr. Excuse me, we're going to do dy d theta this time, right? Divided by dx d theta. Now, we can do dx d theta, right? That's going to be negative e to the negative theta cosine theta minus e to the negative theta sine theta, okay? Now, the top is going to look like negative e to the negative theta sine theta. Plus, and then I get e to the negative theta cosine theta. Now, we want to know what dy dx is at theta equal pi. But there's something I want you to keep in mind. What is sine of pi? Sine of pi is 0. And so when I replace theta with pi here and over here, the first term in the numerator and the second term in the denominator, those are gone, right? And so what do I get? I get e to the negative pi cosine pi divided by, and then it's negative e to the negative pi cosine pi. And then cosine of pi is negative 1, right? So this is going to cancel. And the correct answer for this one is negative 1. And that's how you do 2C. Let's take a look at 2D, right? So on 2D, we have r equals 3 plus cosine 3 theta, and theta equals pi over 2. We're basically going to do the same thing again. So I'm going to start off with y equals r sine theta and x equals r cosine theta. And then what I want to do is I want to figure out dy d theta. So this is dr d theta sine theta plus r cosine theta, right? Now, dr d theta by the chain rule is negative 3 sine 3 theta times sine theta, okay? Plus 3 plus cosine 3 theta times cosine theta dx d theta. You get dr d theta cosine theta minus r sine theta. And we got to make our substitution again. So dx d theta is, now dr d theta is, so if we go back, right, dr d theta is negative 3 sine 3 theta. and then I'm going to multiply by cosine theta. And I'm going to go plus, and then, well, or if it's easier, we can do minus. So I'll do minus. It's either minus r or plus a negative r, right? And then I'm going to put r, which is 3 plus cosine 3 theta. And then I'm going to multiply by sine theta. Okay. Now, dy dx is dy d theta divided by dx d theta. Now, the numerator is this mess. So I'm going to get the following. Negative 3 sine 3 theta. And then I'm going to multiply by sine theta. Plus, and then I get 3 plus cosine 3 theta times cosine theta. So that's the top. The bottom is negative 3 sine 3 theta cosine theta minus 3 plus cosine 3 theta times sine theta. All right, now, I want dy dx at theta equal pi over 2. Now, let's see what we can do with this. Now, sine of 3 pi over 2 is negative 1. So I'm going to get negative 3 times negative 1. Sine of pi over 2 is 1. So I get that. Now, remember something. Cosine of 3 pi over 2 is 0. And same with cosine of pi over 2. So cosine of pi over 2 is the same as cosine of 3 pi over 2, which is 0. So I get 3 plus 0 times 0. That's the top. The bottom is negative 3 times negative 1 times 0 minus. And then, now, cosine of 3 pi over 2, because remember, we're evaluating at pi over 2. Cosine of 3 pi over 2 is 0, so we get 3 plus 0. And then sine of pi over 2, that's 1. So we get that. So negative 3 times negative 1 is positive 3. Positive 3 times 1 is 3. So I get 3 on top. On the bottom, I get negative 3. And so the correct answer here, so dy dx at theta equal pi over 2 is negative 1. And that's how we do problem number 2D. So let's take a look at 3A. So here I have x equals t plus sine of t, right? And then I have y equals t minus cosine t. And what do I want to do first? I want dy dx. Well, that's dy dt divided by dx dt, right? So dy dt is 1 plus sine of t. Dx dt is 1 plus cosine t. And that's how we do the first derivative. The second derivative, that's the derivative of the first derivative. Okay, now, but remember, so the way this works is we're going to differentiate dy dx with respect to t and divide by dx dt. So it's a teeny tiny bit of process, okay? So how does that work? Well, dx dt is 1 plus cosine t, right? So in the denominator, we have 1 plus cosine t. That one's not so bad. So we're going to make a little bit of room here, and we're going to look at the top. So I'm going to take the bottom, which is 1 plus cosine t, and I'm going to multiply by the derivative of the top, which is cosine t, minus the top, which is 1 plus sine of t, right? And I'm going to multiply by the derivative of the bottom, which is negative sine t, and I'm going to divide by 1 plus cosine t squared. And we could pretend like this one's over 1, right? And so how do we simplify this? The denominator is 1 plus cosine t cubed. Now, what does the numerator look like? Well, it's cosine t plus cosine squared t, right? A negative times a negative is a positive. So I get plus sine of t plus, okay, plus sine squared t. This one simplifies really, really well, because what is cosine squared t plus sine squared t? That's 1. And so the second derivative of y with respect to x is, I'm going to get 1 plus cosine t plus sine of t. And then I'm going to divide by 1 plus cosine t raised to the third power. It's a really good question. Now, let's take a look at 3b. And we'll come over here. On 3b, we have x equals 1 plus t squared, y equals t minus t cubed, and we're going to do the same thing. dx dt is 2t. dy dt is 1 minus 3t squared. So dy dx is dy dt divided by dx dt, okay? And so this is 1 minus 3t squared divided by 2t. So that one's usually not so bad. It's the next one that could be interesting. But what I would do here is I would split the fraction. I would write this as 1 over 2t minus 3 over 2 times t. So believe it or not, that'll make this a little bit easier. Now, one thing to recall, the derivative of 1 over t with respect to t is negative 1 over t squared, okay? From here, the second derivative of y with respect to x is the derivative with respect to x of dy dx. And so we're going to take the derivative of dy dx with respect to t, and I'm going to divide by dx dt. Okay, now, dx dt is 2t. So second derivative of y with respect to x. In the denominator, I get 2t. In the numerator, right, I'm going to differentiate this guy with respect to t. And when I do, I get negative 1 over 2t squared for the first term minus 3 halves. So it's just like this. Now, I would expect you to be able to simplify. And then the question is, how do we simplify? The easiest way to go here is we're going to multiply the numerator and denominator by 2t squared. That's going to immediately kill off that fraction. And so in the denominator, we get 4t cubed. In the numerator, we get negative 1 minus. The 2's cancel, and we get minus 3t raised to the second. So again, we're calling this the second derivative of y with respect to x. And that's how we do number 3b. Let's take a look at 4a. Here we have x equals 3t squared, y equals 2t cubed, and then t is less than or equal to 2 and greater than or equal to 0. And we want to find the arc length, okay? Now notice, dx dt is 6t. dy dt is 6t squared. My arc length, that's the integral from 0 to 2 of the square root of 36t squared plus 36t to the fourth. So I square this guy, I square this guy, and then I add. And remember, we're going to integrate with respect to t. So I'm going to factor out a 36t squared. And when I do, I get 1 plus t squared dt. But the square root of 36 is 6, right? The square root of t squared is t on the interval 0 to 2. So this is the integral from 0 to 2 of 6t times the square root of 1 plus t squared dt. So it works out really, really nice, okay? Now, I'm going to let u equal 1 plus t squared. du is 2t dt. So t dt is 1/2 du. Now, when t is 0, u is 1. When t is 2, u is 5. I plugged in up here. So this is the integral from 1 to 5 of. Now, I'm going to take that 6 and divide by 2 and get 3 times the square root of u du. Because remember, t dt becomes 1/2 du. So I'm going to take half of 6 to get 3. That's the idea. And so this is 3 times 2/3 u to the 3 halves, evaluated from 1 to 5. The 3's cancel. I'm going to pull that 2 out, and I get 5 to the 3 halves, right, minus 1. And that's, again, times 2. So we get 2 times the quantity, 5 to the 3 halves minus 1. So the correct answer here for this arc length is 2 times 5 square root of 5 minus 1. And that's how we do problem 4A. And then I will save 4B for a different video. And so that'll conclude this video. It's on the Chapter 10 review. We looked at problems 2, 3, and 4A. Thank you.